Assuming the service cable is adequately sized to handle a 400 amp service, adding two 100 amp circuit breakers to feed subpanels is feasible, but several conditions must be strictly observed to ensure safety and compliance with electrical codes. Firstly, the main service panel's amperage rating is paramount. The existing panel must be explicitly rated to handle 400 amps. This rating indicates the panel's capacity to safely conduct and distribute the increased current without experiencing overheating, component failure, or posing a fire hazard. The physical busbars, the enclosure, and all internal components must be designed and certified to withstand the elevated amperage. Secondly, replace the 200 amp main circuit breaker with a 400 amp main circuit breaker. The main circuit breaker serves as the primary overcurrent protection device for the entire electrical system. Upgrading to a 400 amp breaker ensures that it can accurately and reliably trip in the event of an overload or short circuit, safeguarding the panel and downstream circuits. It's crucial to select a circuit breaker that is compatible with the existing panel and carries the appropriate Underwriters Laboratories or UL listing. Thirdly, the subpanels receiving power from the new 100 amp circuit breakers must also be adequately rated. Each subpanel must have an amperage rating sufficient to handle the anticipated load connected to it. If the detached garage subpanel will serve heavy-duty equipment like welders or air compressors, a higher amperage rating might be necessary. Employing subpanels with ratings lower than the connected load can lead to overheating, nuisance tripping, or even electrical fires. When these conditions are met, adding subpanels can be a cost-effective and flexible solution for expanding electrical capacity. Cost savings are realized by avoiding a complete service upgrade, which often involves replacing the meter socket, service entrance conductors, and potentially incurring higher utility connection fees. Adding subpanels typically involves lower material and labor costs compared to a full service overhaul. Flexibility is enhanced because subpanels allow for dedicated circuits for specific areas or appliances. This makes it easier to manage and distribute power according to the needs of the house and the detached garage. For example, the garage subpanel can be tailored to handle power tools, lighting, and other equipment independently from the house circuits. Safety is maintained by ensuring that all components are correctly sized, installed, and grounded according to the National Electrical Code, or NEC, and local electrical codes. Proper wiring practices, secure connections, and the use of appropriate overcurrent protection devices are crucial for preventing electrical hazards. It is important to consult the NEC for specific requirements related to conductor sizing, overcurrent protection, grounding, and bonding. For instance, NEC Table 310.16 provides ampacity ratings for conductors based on their insulation type and installation conditions. When selecting conductors for the 100 amp circuits feeding the subpanels, it is important to consider the ambient temperature and derivative factors specified in the NEC. Grounding and bonding are essential for providing a low impedance path for fault current to return to the source, which helps to trap over current protection devices and minimize the risk of electric shock. The NEC specifies requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. For example, the grounding electrode system may consist of a ground rod, ground ring, or connection to a metal water pipe. Equipment grounding conductors must be properly sized and connected to all non-current carrying metal parts of electrical equipment. Bonding jumpers are used to connect metal enclosures and raceways to the grounding system. Adding subpanels to an existing electrical system requires careful planning and execution to ensure that it meets the electrical needs of the house and the detached garage. The NEC is a comprehensive set of standards that provides guidance on safe and reliable electrical installations. It is also essential to follow the manufacturer's instructions for all electrical equipment and components. These instructions provide specific information on installation, operation, and maintenance. Ignoring the manufacturer's instructions can lead to improper installation, equipment failure, or safety hazards. Proper planning involves assessing the existing electrical load, determining the anticipated load for the detached garage, and selecting components with appropriate ratings. It is also important to consider the location of the subpanels and the routing of conductors. The subpanel should be installed in a dry, accessible location, and the conductor should be protected from physical damage. Furthermore, adherence to the NEC and local codes is essential for legal compliance and ensuring the safety of the electrical system. Electrical codes are designed to protect people and property from electrical hazards. Failure to comply with these codes can result in fines, penalties, and potential liability in the event of an accident. Always consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with applicable codes and regulations. For example, an electrician can perform a load calculation to determine the total electrical load of the house and the detached garage. This calculation will help to determine the appropriate size for the service entrance conductors, the main circuit breaker, and the subpanels. An electrician can also inspect the existing electrical system to identify any potential problems or hazards. This inspection can help to prevent electrical fires, electric shocks, and other accidents. In addition, a qualified electrician can ensure that all electrical work is properly grounded and bonded. Grounding and bonding are essential for preventing electric shock and ensuring the safe operation of electrical equipment. The National Electrical Code, or NEC, is a set of standards that provides guidance on safe and reliable electrical installations. The NEC is updated every 3 years to reflect changes in technology and best practices. Local electrical codes may also have additional requirements that must be followed. To reiterate some key points, consider the amperage ratings. Every component, from the main service panel to the subpanels, must be rated to handle the intended amperage load safely. Undersized components can lead to overheating, failure, and potential fire hazards. Furthermore, proper overcurrent protection is important. Circuit breakers and fuses protect circuits from overloads and short circuits. Ensure that the overcurrent protection devices are properly sized and installed to prevent damage to equipment and wiring. Grounding and bonding is the provision of a safe path for fault current to return to the source, which helps to trip overcurrent protection devices and minimize the risk of electric shock. Follow the NEC guidelines for grounding and bonding to ensure the safety of the electrical system. Lastly, consulting a licensed electrician is crucial. Electrical work can be dangerous, and it is important to have a qualified electrician perform any electrical work. A licensed electrician has the training, experience, and knowledge to ensure that the work is done safely and in accordance with applicable codes and regulations. In a specific scenario, adding two 100-amp circuit breakers to feed subpanels is a viable option if the existing service cable is large enough to support a 400-amp service and if the main service panel is rated for 400 amps. However, it is essential to upgrade the main circuit breaker to a 400-amp breaker and ensure that the subpanels are also adequately rated for the anticipated load. In addition, it is essential to follow all applicable codes and regulations and to consult with a licensed electrician to ensure that the work is performed safely and correctly. Also, proper labeling is key. Clearly label all circuit breakers and subpanels to indicate their function and the areas they serve. This helps with troubleshooting and maintenance. Regular inspections are important to identify and address any potential problems before they become serious hazards. Look for signs of overheating, corrosion, or damage to wiring and components. Replacing the 200-amp main breaker with a 400-amp breaker is vital for safety. The 400-amp breaker will protect the entire system from overloads. The 100-amp breakers feeding the subpanels will protect the circuits within those subpanels. The subpanels themselves must be rated appropriately with attention to conductor sizing. Choose the correct wire gauge for each circuit based on the amperage and length of the run. The NEC provides tables to determine the appropriate wire size. Use approved wiring methods such as conduit or cable and secure all connections properly. Also remember to use appropriate conduit fill. Don't overcrowd conduits with too many wires, as this can lead to overheating. Follow the NEC guidelines for conduit fill ratios. And speaking of junction boxes, use them to make splices and terminations. Junction boxes protect connections from damage and provide a safe enclosure for electrical components. Use the correct size junction box for the number of wires and connections. Lastly, consider surge protection. Install surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protectors can be installed at the main service panel or at individual outlets.